weather forecasting and crop yield prediction using machine learning model. Now coming to our team members, we are the team of 5: Sumant, Manish Kumar, Jonathan, Kavya Nagasri and Pravina. Now coming to agenda, first we will go through about the project and what we are aiming to achieve, then from where we obtain the data sources, which model we had built, deployment, key findings and further project details. Now coming to about our project. Over time, US weather patterns have been changed. So we evaluated the past changes in the US weather by covering temperature, precipitation and extreme weather occurrences. And also we examined agriculture data, which involves analyzing various aspects of crop productivity and land usage. Next, we had uncovered correlations between weather variables and agriculture outcomes, involves identifying and understanding the relationship between various weather factors and their impact on agriculture activities and their outcomes. By these findings, we can provide practical advice for farmers and other stakeholders in the agriculture. And we had developed an advanced machine learning model to predict crop yields and weather conditions. Now, what are we aiming to achieve? As we said, we assessed the historical trends in US weather patterns including temperature, precipitation and extreme weather events. And also we analyzed agriculture data focusing on crop yields and land usage. We unearthed the correlations and patterns linking weather variables with agriculture outcomes. And we can deliver actionable insights for farmers and stakeholders within the agriculture sector. And also we constructed an advanced machine learning model to forecast crop yields and weather patterns. Now coming to methodology overview. Data sources. We had collected weather data from National Centers for Environmental Information, that is NCEI, and agriculture data from the National Agriculture Statistics Service, that is NASS. And dataset pre-processing. In dataset pre-processing, we clean the data by handling missing values and the outliers and the errors. In exploratory data analysis, we analyzed and visualized data to understand its main features and detect the patterns and identify the anomalies. And we had built a machine learning model to predict the yield and weather patterns, and then we evaluated the model performance. Now coming to data sources. As we said before, we had obtained weather data from the National Centers for Environmental Information. It offers the historical weather data from various regions across the US and the spanning several decades. And we acquired agriculture data from National Agriculture Statistics Service, which provides a detailed information related to crop yields, production, land usage and farm operations throughout the United States. Now coming to regression model for agriculture. We had used regression technique to accurately estimate the crop yields. To handle the categorical columns in our dataset, we applied the technique like ordinal encoding and the label encoding to transform categorical information into a suitable format that can be utilized by the machine learning algorithms. By transforming these categorical variables, we improved the predictive performance of our models and enabling them to effectively utilize all available data for accurate predictions. To address the data inequality concerns, we split our data into 80/20 ratio, that is 80 for training and 20 for testing. And our technique uses separate models for each crop to improve the accuracy and effectiveness of our predictions. This is the output for regression model. We used a XGB regression model and we got the accuracy like 93.74. LSTM model for weather. We used LSTM model to predict the weather data. We structured our data set by setting the date column as the index and converting it to the datetime format. We selected specific columns such as precipitation, snow, snow wind, T average, T max and T mean for the LSTM analysis. To assess the model's accuracy, we used evaluation metrics such as mean absolute error, mean squared error and the root mean squared error, comparing the predicted values to the actual values. And this is the output for LSTM model. Coming to streamlining analysis and deployment. This is the interactive user interface which we had created. We implemented an automated continuous integration and continuous deployment pipeline to facilitate smooth testing and deployment of code changes, ensuring the efficient transition to production environments. Additionally, we developed an interactive user interface that enables users to input their specific values for analysis purpose. The interface supports 78 potential predictive variables, including monthly weather averages generated from the weather LSTM model. Through this system, stakeholders receive predictions of yield values, which significantly improve decision-making process by providing valuable insights based on user-defined inputs and predictive analysis. Now coming to key insights. The LSTM model shows encouraging accuracy in forecasting weather patterns by effectively capturing temporal dependencies within the data. Although most variables are predicted accurately, slight discrepancies are observed in precipitation predictions compared to the actual values. On the other hand, the regression model shows satisfactory performance in predicting crop yields by considering various factors, including weather variables. Through future importance analysis, we identify the significant influence of variables such as acres harvested, acres planted, and specific months of weather variables on crop yields. These insights is valuable for farmers and policymakers in developing strategies to improve agriculture product. For further project details, we had given the links to our web app and GitHub repository and the final report. These are the references which we have gone through our project. Thank you.